Hello and welcome to another video. In this video we're going to be doing the third problem of the weekly contest 382, which is Alice and Bob playing flower game. In this problem, Alice and Bob are playing a turn-based game on a field surrounded by flowers. The circle represents the field and there's X flowers in the in the clockwise direction between Alice and Bob, and Y flowers in the anti-clockwise direction. The game proceeds as follows. Alice takes a turn. In each turn, a player must choose either the clockwise or anti-clockwise direction and pick a flower. At the end of the turn, if there's no flowers left at all, the current player captures their opponent and wins the game. Given two integers n and m, the task is to compute the number of possible pairs x and y that satisfy the conditions. Alice must win the game according to the described rules. The number of flowers in the clockwise direction must be in the range of 1 to n. Number of flowers in the anti-clockwise must be in the range of 1 to m. And return the number of possible pairs that satisfy the conditions. So in this first example, for n equals 3 and m equals 2, these pairs satisfy, and for the second one, there are no pairs. So first, you kind of have to really kind of understand what the game is. Once you understand the game, I think this is a very, very easy problem. Probably the easiest third problem I've seen in a weekly contest. So essentially, you have Alice and Bob here. And you have so let's call this top the clockwise section of flowers with x. So let's just say we have X flowers here, and then we have Y flowers here. And basically Alice picks first, and Alice can pick from either direction. Just pick one flower. Then Bob can pick from either direction, one flower. And then this keeps on happening, and the person that picks the last flower wins. So you can kind of figure out that because you can pick from any direction, these two things don't really matter. It just comes down to how many total flowers are there at the start of the game. So if there's an odd number of flowers, Alice will always win. And if there's an even, Bob will always win. So for example, if there's an odd total, let's just say we have 3 and 2 here. Alice will pick one, doesn't matter which one. Let's say picks here, that would be 2. Bob picks 1, Alice picks 0, Bob picks, and then Alice picks, right? So if there's odd, Alice will get the last flower and win. And if there's even, Bob will get the last flower and win. So now that we know that means we know that for sure, right? So if odd total, Alice wins. If even total, Bob wins. So now let's just check the second part of the problem and figure out exactly what they want. So given two integers, n and m, the task is to compute the number of possible pairs, x and y, that satisfy the conditions. So Alice has to win, so the total number has to be odd. And the number of flowers of x needs to be 1 to n, and y needs to be 1 to m. Return the number of pairs. So essentially what they're saying is x plus y has to be odd. X is in the range 1 to n, and y is in the range 1 to m. So now we can look at the examples and really have a good understanding. So for x being 1 through 3, x can be 1, 2, or 3, and y can be 1 or 2. So let's say we pick 1 for x. What does y have to be? Y can be 1 or 2, and we need this whole thing to be odd. So y has to be 2, right? Because you need this whole thing to be odd. So this is 1. Then for x equals 2, y has to be odd, because the whole thing has to be odd. So y has to be 1, because it can only be 1 or 2 to be in this range. And for x equals 3, y has to be even. So if you take a look, 1, 2, 3, 2, and 2, 1. And the last example, so if x and y can only be 1, there are no pairs, because if they're both 1, Alice will never win. Right? So there are no pairs. So if x and y can only be 1, the only pair that you can pick is 1, 1, and that's even, so Alice will never win. So that's why this is not the case. So essentially, we can rewrite this as for every value x in the range 1 to n, y can be any value in the range 1 to m where, so let's do these two conditions. So if x is odd, y has to be even. If x is even, y has to be odd. So really, you can calculate this, and you can do some kind of solution where you can figure this out. going through every value of x. But notice that we can just do like a basic combinations problem, right? Like we can make this even simpler. So we can say if x is odd, y has to be even. If x is even, y has to be odd, right? And basically the number of combinations is this one is like one or the other, right? So we can just calculate how many odd x's there are, how many even y's there are, how many even x's there are, and how many odd y's there are, and just do a basic sum there, right? So it's going to be like odd x's times even y's plus even x's times odd y's, right? So we don't need to like go through and figure out every single combination. We just need to figure out for the range 1 to n how many numbers are odd and how many numbers are even, and then for this range, same thing. So let's just say n is like 10. The way to figure out how many numbers are odd, and you can kind of like try a bunch of numbers, you can just basically divide by 2 and do a ceiling divide. Because if n is even, right, like if n is even, there will be n over 2 odd numbers. So if n is 10, there will be 5 odd numbers, right? 1, 3, 5, 7, 9. And if n is odd, there's going to be one more odd number than even, because odd comes first if you do 1 to something, right? Because it's like odd, even, odd, even, odd, even. So essentially, you just do a ceiling divide. So here, you would get 4.5 or end up to 5, and there would be 5 odds. So that's how you figure out how many odd numbers there are. So you just calculate odd n's, and then to get the even n's, you can either take n and do a floor divide, or you can just take how many n's there are total and subtract odd n's, right? So you can say even n's is going to be, or x's, is going to be total x's minus odd x's. So that's one way to do it, or like I said, you can do another divide. And same thing with even y's is going to be total y's minus odd y's. And we can basically do this in O of 1, right? So given some range for y, let's say y is like 15, we can figure out like, or let's say m is 15, right? That y has to be in. So y has to be in this range. We can figure out how many odd values there are and how many evens. So we would take this, divide by 2, ceiling divide, we would get 8. So odd equals 8. And even is just the total minus odd, so even equals 7. Then we just literally do this formula, right? Where we just say, okay, since we know that it's one of these, we can just multiply the odd x's times the even y's plus the even x's times the odd y's. And that's basically it. So you can actually get an O1 solution. So this whole like problem, there's a bunch of like random stuff that you just have to realize doesn't really matter. And all you have to realize is for any odd number of total flowers, Alice wins. And you just have to figure out like how many different combinations are there to give you an odd result. And that's how you do it, right? So it's either even plus odd or odd plus even. Figure out those numbers and just do a basic combinatorics problem. And so yeah, so let's take a look at the code. Very easy, right? So here it is. So I just calculated the number of odds that x can be, the number of evens x can be, the number of odds y can be, the number of evens y can be, and it's just a basic, if x is odd, y has to be even, so let's just multiply the number of each of those, and that'll be the number of combinations, and if x is even, then y has to be odd, let's multiply the number of those can be, and yeah, that's basically it. So this is just an O of 1 O-space solution. So I do think this is like way easier than most third problems on the weekly contest, so. And I have to do the fourth one left, which is an 8-point problem, so that one might take me a while. I haven't really looked at it, so we'll see how that goes. But yeah, this is just going to be O1 space and O1 time. Pretty rare, pretty easy, so yeah. If you have any questions, as always, you can write in the comments, but yeah, definitely surprising that this problem was asked as the third one, so let me know what you guys think. Let me know if you found it as easy as I did, or maybe I'm just like good at some problems, I don't know, but I did find this to be a lot easier than most. So I definitely think it's pretty reasonable, even if you haven't done too many contests, that you should have been able to finish the first 3 problems here. Sometimes the third problem is actually harder than the fourth problem, and sometimes it's like nowhere near medium. But in this case, I'd say it's like an easier medium. So yeah, that's going to be all for this one. And if you did like it, please like the video and subscribe to the channel. And I'll try to post the fourth one in the next few days. So thanks for watching.